This historic power plant is about to close down forever. But inside, much of the original equipment is still here, silent and abandoned. The coal boilers and turbines no longer run, while modern Scotch boilers keep the system alive, at least until October. Hello, I'm your host Jason from Steam, Electricity, and Propulsion. Let's take a final look at the steam plant in Virginia, Minnesota. Let's start with the 3 different boilers. This coal-fired unit is a Riley boiler with 5 Riley stokers, something you don't see very often anymore. Coal was fed in by gear-like mechanisms, each driven by variable-speed DC motors. Next is the oldest boiler here, a Wix boiler from around 1954. It uses a Detroit stoker system, driven by a shaft with an electric motor on one end and a small steam turbine on the other. In the back is another boiler that stands out. At first glance, it's just a gas-fired O-type unit. But it was built by Zurn, which is less common. I've only seen one other Zurn boiler, which was the coal boiler at NDSU. Right behind the Wix boiler is the locker room and bathroom, where operators would clean up after their shifts. Just outside are the water softening tanks. Together, these boilers supplied 600 psi superheated steam to the turbine generators. The building itself is also older. Brick walls, large windows, a simple layout that you don't see much anymore. While most of the plant is now abandoned, the city still needs steam for heating. Inside the old turbine hall are 2 Cleaver Brooks Scotch boilers that now supply that steam. These are a double pass design, which is a bit unusual. I've seen a similar setup at the North Dakota State Hospital, although those are 4 pass and don't use an economizer. Because of the double pass design, these boilers rely on economizers to improve efficiency. They also operate separately from the rest of the plant, with their own deaerator and feed water pumps. These Scotch boilers produce 50 psi steam for heat only. In the original system, steam was extracted for heating while the rest continued through the turbines. After leaving the turbines, the steam is condensed back into water. Inside the condensers, lake water flows through small tubes while the steam passes around them, cooling and condensing.
Probably about 7,000 tubes in there. And then one behind this is a little smaller, there's probably about 500. Same size tubing themselves, 3/4 inch.
Out by the lake, circulating pumps move that water to carry the heat away. This strainer keeps debris out of the pumps. Each turbine used 2 pumps for rapid cooling, and just behind them is the coal dumping pit. The condensed water is then pulled out by condensate pumps and sent through a steam heater. Before it can return to the boilers, it has to be stripped of dissolved air. In these deaerators, the water is heated with steam and spread over trays, allowing the air to be vented off. From there, it is stored in large tanks before going down to the feed water pumps. Here you can see one electric pump and one steam-driven unit. One of these turbine-powered pumps was even sent to the Hibbing power plant about 25 miles away. At Virginia Public Utilities, water is also treated in addition to providing district heating. First, water is pumped from an abandoned iron mine pit into this room. Chlorine from this tank is pumped into the water to kill bacteria. Inside this room is where fluoride is injected. After this, the water is sent across the street to filtering tanks. These pipes allow sludge trapped in the filters to be flushed out. These motors drive multi-stage pumps that send the water into the water tower. Now that we've seen how water is treated, let's return to the power plant. Now let's explore the top level of the plant. This conveyor belt comes up from the coal pit we saw earlier and carries the coal up to the bunkers. From this conveyor belt, coal can be directed into any of the 3 bunkers. Behind the conveyor belts is the draft fan room. Here is the top of the Riley boiler, and you can see the steam drum. The base of the smokestack is also visible here. This large fan provides induced draft for the Erie City boiler beneath it. Normally, this electric motor would power the fan, but on the other side of the shaft is a dismantled turbine. This allowed the plant to operate during a power outage, though systems like this are very rare today. The forced draft fan on the Wicks boiler uses a similar setup. Inlet dampers on this fan are controlled by a pneumatic piston. Up on the roof, we see the water tower and the smokestacks from each boiler. Now we're going to see a boiler that was only used for about 10 years. Down this hall is the original boiler room, but those earlier boilers had already been replaced by the coal-fired units we saw earlier. Around 2007, a wood-fired boiler was added here. Here's a look inside the furnace where you can see the water wall tubes and grate. This is from a similar boiler in Hibbing. Wood was fed down these chutes and blown across the grate with air.
You want to see the augers are up there?
These augers are from a similar boiler at the Hibbing power plant. Leaving the wood-fired boiler room, we arrive back at the Riley boiler. Right in front of it is the control room. Let's take a quick look at the analog controls. These paper charts rotate once a day while pens trace data onto them. These gauges show voltage and generator output, and pneumatic controls were used to adjust airflow and steam temperature. Charlie, the plant manager, gave me a manual for these Bailey meters. We'll take a closer look at that in another video. Places like this are fading away, and once they're gone, they're often forgotten. If you'd like to see more, consider joining the channel. There's more members-only content coming soon.